All right, second derivative, concavity. All right, so second derivative. Your second derivative in written form looks like f double prime of x equals, remember the d over dx that I've shown you before? But now here it's going to be f prime of x. All right, I wrote that kind of upwards. All right, so it's d, so the derivative of the first derivative is the second derivative. All right, now what does this have to do with concavity? If I can spell. All right, well, concavity is a measure of the degree to which a graph curves upwards or downwards. All right, that is concavity. A measure of the degree to which a graph curves upwards or downwards. So what exactly does that mean? Well, if you have a graph that's in this shape like this, right, not only is this increasing, all right, it is also curved upwards. All right, so it is said to have a positive concavity, or its concavity is positive. All right, easy way to remember this. Positive concavity kind of looks like a smiley face. All right. Now, if you have a graph that looks like this, all right, this is also increasing. All right, but it is set, but this is curved downwards. All right, and it has a negative concavity. Easy way to think about this is it's a frowny face. All right, and then if you just have a straight line, even though this is increasing, it has no curve, so it has zero concavity. Whoops. All right, so increasing concavity kind of looks like a smiley face. I mean positive concavity, sorry, kind of looks like a smiley face. Negative concavity looks like a frowny face. And if it is a linear graph, it has no curve, therefore has zero concavity. All right, no curve, therefore zero concavity. All right, so your concavity test. All right, your concavity test. If f double prime of x is greater than 0, so that means it's positive, all right, then f of x, so your original graph, is said, oops, to be concave up. All right, if f double prime of x is less than 0, then it is said to be concave down. All right, it is said to be concave down. Let's look at a problem. Say f of x equals x squared. We want to find all concavities. Step one, we need to get f prime, f double prime, sorry. So get f double prime. So first, for that, we first need to get f of x. F of x squared is 2x. And then you take the derivative of that to get f double prime. Well, the derivative of 2x is 2. So can we set, well, I'm getting ahead of myself here. So step 2, we gotta get the criticals. Get the criticals. And you get the criticals of the second derivative the same way you did the first. You take f double prime, set it equal to 0. Well, can we set 2 equal to 0? What is that? So we can't do that. We can't set f prime equal to f double prime equal to 0. Is there any places where f double prime does not exist? Nope, because it equals 2. So because of these two cases, this graph is said to have no criticals. Oops. All right. Now, ask yourself, in this case, what is f of x always? I mean f double prime of x always. Well, f double prime of x equals 2. So it's always 2. And 2 is positive. Alright, since 2 is positive, this graph is always concave up. Alright, this graph is always concave up. So that's why we have no criticals. Because if you think about it, alright, if you think about it, the graph of x squared looks like this. That's always going to be concave up. It looks like a smiley face. We're going to put 2 eyes in here. Right? It looks like a smiley face. It's always going to be concave up. And also, don't make this mistake. Don't put the 2 on a number line thinking it's a critical value. Right? This is wrong. Because 2 is not a critical value. Right? 2 is not a critical value. So don't make this mistake. This is wrong to do this. Right? When you get a constant, like we did, we got f double prime equals 2. Since that constant is positive, your graph will always be concave up. If that constant was negative, your graph would always be concave down. All right. Let's look at another one that actually is going to have an interval. All right, say f of x equals x cubed. All right, so step 1, we got to get f double prime. Oops. All right, well, we know f prime is 3x squared, so we know f double prime is 6x. So now step 2, we got to get the criticals. All right, so we take f double prime, set it equal to 0. 6x equals 0. So x equals 0. Can we do f double prime does not exist? No, we cannot. So we don't have to worry about this case at all. Isn't it nice how this case cancels out most of the time? We don't really have to worry about it. All right, so now that we have f double prime, and it actually has a variable in it, and we found a critical value, all right? And we found a critical value. Critical value is x equals 0. Let me star the critical value. All right, so now we need to try a point on this side. We need to try a point on this side, just like we were doing before. If we put in -1, we get 6 times -1, negative. Put in +1, 6 plus 1, positive. All right, since it's negative here, the graph is going to be concave down. All right, because x is less than 0. Alright, so we have our frowny face over here. Put two little eyeballs on it. Okay, or you can write your interval as negative infinity to 0. Alright, so I could take x as concave down for x is less than 0 or negative infinity to 0. And over here it's positive, so that means it's concave up for x is greater than 0. So I'd take that, or you could write it out in interval notation, 0 to infinity. So over here it's concave up, so it's happy. Alright, and to verify that, if you were to graph your x cubed, remember your x cubed graph looks like this. So from negative infinity to 0, you can see it's concave downward, and then after 0, it is concave upwards. Alright, that's supposed to be a little bit more rounded out there. I kind of messed it up a little bit. So, that's concavity. I am going to give you a U-try. It's a little tougher than the two I did, but still, you should be able to manage it. So, f of x equals 2x to the fourth minus 8x plus 3. Alright, so find my interval for concavity. Alright, so step 1. We had to get f double prime. Alright, so f prime of x equals, drop the 4 down, 8x cubed minus 8. And then take that and turn it into f double prime, which equals 8 times 3, which is 24, x squared. So there's our double prime. Alright, now we have to find our criticals. That's step 2. Get the crits. Alright, so you take f double prime. But let's start out with a does not exist case. Is that going to matter here? Not at all. So you take f double prime, set it equal to 0. So 24x squared equals 0. Divide both sides by 24, you get x squared equals 0, so x equals 0. Alright, so number line time. Alright, so here's x, our critical point in the middle, which is 0. So try a point on both sides. Plug in a -1, -1 squared is 1 times 24, that's positive. Plug in 1, 1 squared, that's 1 times 24, that's positive. And if you plug in 0, you plug in our critical point, you get 0. Alright, so it's positive here, and positive here, but here it's 0. Alright, so what does that mean? Alright, what does that mean? That means that our graph, because this is positive, since this here is positive everywhere but 0. Alright, since it's positive everywhere but 0, and this confirms that it's positive here, and 0 here, that means our function 2x to the fourth minus 8x plus 3 is concave up for all except where x equals 0. Alright, so concave up for all x is not equal to 0. Alright, so it's concave up everywhere but x equals 0. Alright, so there's no ticket in the door for this one. Hopefully you got the you try right. If not, hopefully now you understand what the process is to figure this out. So this is your second derivative. It works just like your first derivative. You find your f double prime, then you find your critical values. You put them on an if your f double prime is not a constant, you find your criticals. You put your criticals on a number line, test a number in each interval, so to speak. And if that interval is negative, it's concave down. If it's positive, it is concave up. If it comes out to 0, it's neither concave up nor concave down, because 0 is neither positive or negative. All right, so make sure you understand this fully when you come to class. We will be working on some problems over this in class tomorrow.